All right, so now let's talk about proportion. So in a proportion, what we're going to do is we're going to take two ratios and we're going to claim that they are equal to each other. So since we have two different ways of writing ratios, there's also two different ways that we can talk about proportions. We can write them in the A to B notation, right, saying that the first ratio is equal to the second ratio, or we can write it in fraction notation. And so we have ways of talking about the values that are showing up. In this case, if you notice, four values are being compared. And we talk about them as extremes and means, right? And so this is so we can convert between them easily. So if you notice, my extremes are kind of going downhill in my fraction, and my means are going uphill in my fraction. And when I convert that over to the A to B notation, my extremes are the two outside values. So the one on the left is an outside value, right? And the one on the right is an outside value. And then my means are the inside values in my colon notation. So that's a kind of a vocabulary, means, and extremes that you're going to see when we talk about properties of proportions. So the first property of proportions is something that you know, and that is called cross products. And you've used this if you've ever solved a proportion before. Here's the idea for proportions. If I do something like 3/5 is equal to 6 over 10, right? We can kind of look at this and say this is pretty obvious. This is 2 times as big and 2 times as big. So these are equivalent fractions. The cross product property claims that in a proportion, if you multiply together the extremes, which for us is 3 times 10, okay, we get 30. And if I multiply together the means, I get 6 times 5, and that is also 30. And so this is always going to be true for every proportion. It doesn't matter. In the example here, if you notice, 3 times 4 is 12, 2 times 6 is 12, 2/3 and 4/6, that is a true proportion. And this is going to be true all the time for every proportion, right? So this is going to be useful, and you've used this in solving simple problems like 6 over x equals 5 over 4, right? So this is not an easy proportion. How do you turn 6 into 5 using a nice simple number? Well, there is no nice simple number. It's a decimal or a fraction. So what we're going to do is we're going to say 6 times 4 is equal to x times 5, which I'm just going to write as 5x equals 24. And so I'm just going to leave this as the improper fraction 24/5, right? So in this case, the ratio is not really all that nice. 6 over 24/5 is equal to 5/4, and that's my proportion there, right? Not all that nice, but it is the valid proportion. So I can come over here and do this with some algebra as well. And I can check this one, and just be careful when you do your extremes. Y plus 4 times 3 is 3y plus 12, and then 9 times y is just 9y. And so I can solve this one pretty easily. We get that 6y is equal to 12, and then if I divide both sides by 6, I get that y is equal to 2. And I can go back and check this, right? If I plug a 2 in here, this says now 2 plus 4. And I'm also going to plug that 2 in here. If you notice, this says 6 over 9 is equal to 2 over 3. And that's true. That's a good proportion. So we found the value using the cross product property in order to figure out my y value, right? So that's one of the properties of proportions. So there are a few others that are a little bit less known. They're a little bit more obscure. And here they are. Okay, so we're going to say the first property says, okay, that you can flip over, you can take the reciprocal of one of the fractions as long as you take the reciprocal of the other one. So here's a very simple example. 1/2 is equal to 2/4. Okay, so in this example, this first one's saying, go ahead and take the reciprocal of the first one, turn it into b to a. So we're going to do that. We're going to turn it into 2 over 1. Okay, it says you're allowed to do that as long as you also flip over the second one, and it's still true, right? So if you notice, this is 0.5 equals 0.5, right? A half equals a half. And if I flip it over, now it says 2 equals 2. It's still a true proportion as long as I flip over both fractions. So that's all the first property here is saying. Okay, my second property says go ahead and switch either the means or the extremes, and you're still going to have a true fraction. So again, I'm going to stick with this particular one right here, okay? And what I'm going to do is I'm going to switch, right? I'm going to come over here and I'm going to say, let's switch the 4 and the 1, right? So I'm going to say, if I put a 4 over 2, okay, and equal to 2 over 1, well, look, that still works. This is still 2 over 2, right? I actually swapped these two values, and in doing so, I ended up with still a true proportion. It's a different value, still saying 2 is equal to 2 instead of 0.5 equals 0.5, but it's still true, and that's what I care about, that we're allowed to make that change, and we don't change the equality of the proportion. Okay, the last one is probably the least kind of obvious one. What this one is saying is if you add b to the right left-hand side. If you add the denominator of the left-hand side to the left-hand side, that's fine, as long as you add the denominator of the right-hand side to the right-hand side. So let's again take this same example. Right, I'm going to come over here and start a fresh one. 1 over 2 is equal to 2 over 4. Okay, what this one's saying is go ahead and add 2 to the left-hand side. So this will become 1 plus 2 over 2, as long as you add the denominator of the right-hand side to the numerator of the right-hand side. So this now says 2 plus 4 over 4. So let's see what this says. This says now that 3 over 2 is equal to 6 over 4. And if you notice, that is true because 6/4 does reduce down to 3/2, right? So this is just another kind of a property that we can use, which sometimes allows us to simplify or solve more complicated proportion problems, right? So we're going to apply these properties in future lessons in order to expand some of our ideas of proportions, and we'll use some of them in order to solve.